In this video, we're looking at our trigonometric functions. We're going to start defining them. Let's first review a couple of formulas from previous classes. First, the Pythagorean theorem. For a right triangle, the Pythagorean theorem has a relationship to the side lengths of our right triangle, and that is a squared plus b squared equals c squared, or leg squared plus leg squared equals your hypotenuse squared. And also the distance formula. The distance formula, we're going to look at the distance between 2 points on a coordinate grid. So x1, y1, and x2, y2. The distance is equal to the square root of the change in our x's. So x2 minus x1 squared plus the change in our y's squared. So y2 minus y1 squared. Now, the distance formula and the Pythagorean theorem are actually two of the same exact formulas. They're just representing them in different ways. But we're going to be using either of these, more than likely the Pythagorean theorem, because we're going to be setting up a lot of right triangles. So using ordered pairs is just a little bit more tedious, but both can be proven using the other. So our trigonometric functions, that's one of the biggest parts of this course is trigonometry. Let xy be a point other than the origin on the terminal side of any angle theta measured in standard position. Remember, standard position is starting with the positive x-axis. The distance from the point to the origin is r. And we use r because eventually this is going to represent a radius. And that length r is equal to the square root of x squared plus y squared. Now, this does follow from both the distance formula and the Pythagorean theorem. Since we're starting at 0, 0, the distance of our x's, or the difference between our x's, is going to be x, and the difference between our y's is just going to be y. We define the 6 trigonometric functions, and our 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. And in parentheses, you see there are abbreviations, which is what we're going to use when we're writing these symbolically in equations or in any of our work. But those are our 6 trig functions, and they're defined as follows. So if we have this point, again, xy, and that's on our terminal side of an angle who's got a length between the point and the origin of r, sine is equal to y over r. Cosine is x over r. Tangent is y divided by x. Cosecant is r divided by y. Secant is r divided by x. And cotangent is x divided by y. Now, these are all for this angle theta here. Now, one thing that we want to observe is that when we look at sine and cosecant, those values are reciprocals. Same with cosine and secant, x over r over x, and tangent and cotangent. And this is a really common property that we're going to be utilizing a lot, these reciprocal identities of our trig functions. The terminal side of angle theta in standard position through the point 815, find the values of your 6 trigonometric functions of angle theta. So we're going to sketch the picture just like we have up here, but instead of having xy, we're going to have 815 here. Now 815 is in quadrant 1. We're going to go approximately 8 and up 15, trying to be somewhat accurate. So there's our point. And there's our right triangle. Here's theta. So this length is 15. This length is 8. And that gives us that ordered pair of 8, 15 for our point. Sine is going to be the y value, so 15 divided by our radius. While looking at this, this is our radius. So we actually need to calculate that radius before we can complete any of these trig functions with the exception of tangent and cotangent. So to find r, we're going to use the Pythagorean theorem. We know that 8 squared plus 15 squared is going to give me r squared. 8 squared plus 15 squared, 64 plus 225 is 289 equals r squared. And then we'll take the square root of both sides. R is equal to 17. Because r does represent a length, when we take the square root of both sides, we only need to look at that positive root. So now coming back to our 6 trig functions, sine is 15 divided by 17. Cosine is x over r. So I'm, again, just using these formulas right at the top of the page. So 8 over 17. Tangent is y over x. So 15 divided by 8. And then cosecant is the reciprocal of sine. So this is going to be 17 over 15. Secant is the reciprocal of cosine, 17 over 8. And cotangent is the reciprocal of tangent, 8 over 15. The terminal side of our angle is in standard position through the point -4, 3. Find the values of the 6 trig functions of theta. So -4, 3 is in our second quadrant. So there's our point -4, 3. Ooh. And we've set up this right triangle. And really, this is our theta set up inside of that triangle. Now, we can see that this is going to be 3 units, and this is actually 4 units, but because it's in the second quadrant, it is going to be listed as -4. And that's just that we get the right signs for our trig functions. Now, once again, now we've seen that previous example, we need to find the value of r, and we're going to use the Pythagorean theorem to find that. So 3 squared plus -4 squared equals r squared. 9 plus 16 is 25 equals r squared. R is equal to 5 by taking the square root of both sides. Now, you might also recognize, if you remember from geometry classes, there are these special right triangles, and a 3, 4, 5 is a special right triangle. Sine is going to be y over r. So that's going to be +3 over 5. Cosine is x over r, so -4 over 5. Tangent is y over x. 3 over -4, which we can just write as -3 over 4. It doesn't really matter where that negative goes. So we really have 3 over -4, which is the same as -3/4, which is the same as -3 over 4. We don't typically leave fractions with a negative in the denominator. We either bring it out front or move it to the numerator. As we start dealing with algebraic expressions in the denominator, then we have to be a little bit more careful. But when it's just a number, that negative can float. Cosecant is the reciprocal of sine, so 5 over 3. Secant is the reciprocal of cosine, so -5 over 4. Again, just bringing that negative to the numerator. Cotangent is going to be -4 over 3. In this next example, now we're looking at the terminal side of our angle defined by an equation, a linear equation, x plus 2y equals 0. And we know that x is greater than or equal to 0. So we're going to start by just trying to graph this x plus 2y equals 0. To graph this, we want to try to put it in slope-intercept form, so isolating y. So we're going to start by subtracting x. So 2y is equal to -x. And dividing both sides by 2, y is equal to -1/2 x. So we can see that this is in slope-intercept form. We have a slope of -1/2 and our y-intercept is 0. So we have a y-intercept of 0 and a slope of -1/2. So we're going to go down 1 to the right 2 and continue that to create our line. Now I'm going to pick any point on this. I'm going to pick this 4, -2, just to see how we can use it to simplify. But you could do 2, 1 as well. But we're going to create our triangle here. Here's theta, and we're going to use this point for -2. Just reiterating the fact that we did specify that x had to be greater than or equal to 0, which is why we set up our angle over here in the 4th quadrant. So we have 4, this is going to be -2. We need to find the radius. 4 squared plus -2 squared equals r squared. 16 plus 4 is going to be 20 equals r squared. R is equal to the square root of 20, but we're going to simplify this. So 20 is 4 times 5, and that 4 is our perfect square, so we can factor that out. So r is equal to 2 times the square root of 5. Now, if you had chosen a different point, say to -1, you maybe would have had a different value for r, but then your x and y would have also been different. So ultimately, the values for our trig functions would simplify to be the same thing, even though the work would maybe look a little different. So our sign is y over x. So this is going to be -2 divided by, y over r, 2 square root of 5. So I'm going to start by simplifying those 2's, but I want to get rid of that square root of 5 in the denominator. We want to rationalize it. Square root of 5 is an irrational number. That decimal that has no pattern does never end. So we want to rationalize the denominator, and we're going to do that by multiplying by the square root of 5 over the square root of 5. Hopefully this is a quick review from a college algebra class you might have taken. So multiplying across, we get negative square root of 5 divided by the square root of 5 times the square root of 5 is just 5. For cosine, it's x over r. So 4 divided by 2 square root of 5. Again, starting with simplifying, 4 over 2 is going to be just 2. And then we're going to multiply by the square root of 5 over the square root of 5 to rationalize, leaving us with 2 square root of 5 over 5. And tangent, y over x, -2 divided by 4, or -1/2. For cosecant, I'm not going to start with that finalized version of sine to find the reciprocal. I'm actually going to start with what I began with. So we actually had 2 square root of 5 over -2. Again, simplifying this, the factors of 2. So this is just negative square root of 5. Secant, same thing. We're going to start with the reciprocal of where we started. So I'm going to have 2 square root of 5 divided by 4. We can simplify the 2 and the 4 the same way we did before, but it ends up being different. So we've got the square root of 5 divided by 2. And then for cotangent, I am going to use that simplified value for tangent, just taking the reciprocal, so -2 over 1, or just -2. Find the values of our 6 trig functions for angle theta. That goes through -3, 0. -3, 0 is going to be on that negative x-axis. So there's -3, 0. If we think about the value of r is the distance between the origin and our point. So r is 3, and our ordered pair -3, 0. Sine is going to be y over r. The y value is 0 divided by 3, so this is 0. Cosine of theta is going to be x over r, so x is -3. The radius was 3. This is -1. Tangent is y over x, so 0 divided by -3, or 0. Cosecant is the reciprocal of sine, so we're going to do 3 divided by 0, which is undefined. We can't divide by 0. Secant, 3 divided by -3, which is still -1. And cotangent, -3 divided by 0, this is also undefined. So notice this example is a quadrantal angle, an angle whose terminal side is on one of our axes. And now we're seeing some undefined trig functions. So these bullets summarize the condition for undefined function values. If the terminal side of the quadrantal angle lies on the y-axis, so that vertical axis, then tangent and secant are undefined. If the terminal side lies on the x-axis, then cotangent and cosecant are undefined, which is what we saw in this example here. Our quadrantal angle terminates on the negative x-axis. So we can use this information to start building the trig function values for our quadrantal angles. So we're going to look at 4 points representing points on terminal sides. So we're going to look at 1, 0, 0, 1, -1, 0, and 0, -1. Now, it doesn't really matter where those points are because that relationship, as we saw up here, is going to simplify. Looking at cosine, your x value is going to have the same magnitude as the radius, or that value of r. So it doesn't really matter what points we choose. These 4 points are going to be symbolic, though, once we get to learning about the unit circle. So at theta equals 0, that's looking at this point, 1, 0. Sine, remember, sine is our y. Cosine is our x. I'm getting ahead of myself. I apologize. Sine is going to be y divided by r. Cosine is going to be x divided by r. Tangent is going to be y over x. Cosecant, r over y. Secant, x over y. Sorry, x over r. R over x, sorry. R over x, and then x over y for cotangent. Looking at all 4 of those points, when we look at the distance between the ordered pairs and the origin, we're going to know that r is always 1. So sine at 0 is going to be 0, the y value, divided by 1, which is 0. Cosine at 0 is going to be x divided by 1, or 1 divided by 1, or 1. Tangent is y over x, so 0 over 1 is 0. Cosecant is going to be 1 divided by 0, which is undefined. Secant is r over x, so 1 divided by 1, or 1. Cotangent is going to be x over y, 1 divided by 0. That one's also undefined. Now, 0 lies on an x-axis. or theta is equal to 0, has a terminating side on the x-axis. So we do see that cotangent and cosecant are the ones that are undefined in this table. Now, let's look at 90 degrees, where now our ordered pair is 0, 1. So x is 0, y is 1, r is still 1. Sine is going to be y over r, which is going to be 1 over 1 or 1. Cosine is x over r, so 0 divided by 1 or 0. Tangent is going to be y over x, or 1 divided by 0, which is undefined. Cosecant, r divided by y, so 1 divided by 1 is 1. Secant, r divided by x, 1 divided by 0 is undefined. And cotangent x over y, 0 divided by 1 is 0. 90 degrees, that quadrantal angle has its terminating side on the y-axis, so tangent and secant are undefined, which we have shown here. Now I'm going to fill out the rest of this table, but I do encourage you to sit there and reflect. I'm not going to go through all of those steps, but hopefully, or if you want to pause the video and think about it and then come back and check, you could do that. Sine of 180 degrees is 0. Cosine is -1. Tangent is 0. Cosecant is undefined. Secant is -1. Cotangent is undefined. Sine of 270 degrees, -1. Cosine of 270 degrees is 0. Tangent of 270 degrees is undefined. Cosecant of 270 degrees is -1. Secant of 270 degrees is undefined. And cotangent of 270 degrees is 0. Now we would consider perhaps adding a row for 360 degrees, but 360 degrees is coterminal to 0 degrees. So we would just see the same values repeated here. So this is the same as 360 degrees. Oh, just kidding, it's there. But now we can see, I didn't realize it went to the next page. Sorry about that. But we can repeat those values. So 0, 1, 0, undefined, 1, undefined. Using the trigonometric function values of the quadrantal angles to evaluate 3 secant of 180 degrees minus 5 times tangent of 360 degrees. So we can use this table, and right now these tables are going to be really helpful for us to start memorizing some key values. But as we move through this unit and heading into unit 2, a lot of these values you're going to end up having memorized or determining ways or figuring out ways to determine what the values should be. So we'll see that a little bit later, but for right now, we're going to use this table to help us out. So 3 times secant of 180 degrees. Secant of 180 degrees, I'm going to go to my row for 180, find my secant value, that's -1. Tangent of 360 degrees. Tangent, 360 degrees, that's going to be 0. 5 times 0 is 0, so it's just going to be -3.